Hi everyone, this is your notes video for geometric proofs. So what we're going to do in this video is we're going to break geometric proofs apart its uh, into different aspects of writing a proof. So there's a couple of different aspects that you have to know how to do in order to write a geometric proof. One is being able to match statements to reasons or justifications, and then you also have to be able to put those reasons or those paired statements and reasons together in a logical order, right? So if you can do those two things, then you can write a geometric proof, all right? So let's talk about it, all right? So as always, my slides are on the left side of the screen and the notes, your student notes, are on the right side of the screen. So let's take a look first at justifying statements with reasons. So in the previous videos on algebraic proofs, you already saw how you can match algebraic properties to steps in an equation, in solving an equation. So for geometry, we're going to do a very similar thing, just with geometry rules and geometry statements rather than, or not necessarily using those algebraic properties. We will use the algebraic properties sometimes, but we're also going to include some geometric definitions and properties and things like that in our statements. So this first one is just an example, but I'm hoping that you can see how we match the statements that are written to the reasons that are there. Okay, so my first statement here is, if ABE is a right angle, then measure of ABE is 90 degrees. Okay, so you kind of want to think, when you're thinking about this, okay, we're saying if ABE is a right angle, then what's the next logical step? And the next logical step is that that angle is 90 degrees. And the reason we know that is because that's the definition of a right angle. So essentially, what you're asking yourself is, how did I know that? Right? How did I know that? Or why is that statement true? Right? How did I know that? How did I complete this if-then statement? How did I know that? How do I know? How do I know this is true? Okay, what geometry rule or definition or postulate or property, what rule tells me that this statement is true? And so for this one, it's the definition of a right angle. Okay, so part B says, if angle 2 is congruent to angle 1 and angle 1 is congruent to angle 5, then angle 2 is congruent to angle 5. So remember, we did this already with equal signs. Whoops, let me erase because I'm writing this in the wrong order. 1 second. Okay, we did this already when we were talking about algebraic proofs, right? But we have angle 2 is congruent to angle 1, which is congruent to angle 5. So we are cutting out the middleman, right? So remember, whenever we do that, that is the transitive property. I know this looks a little bit different than what you saw when we did it with the algebraic properties, because there's a congruent symbol right here. Your congruent symbol is an equal sign with a little squiggly on top. Okay, the reason that we use the congruent symbol when we're talking about angles as a whole or segments as a whole is because they have a lot of different properties or aspects about them, right? Angles have rays, they have endpoints, they have measurements, right? So we say that angles or line segments or shapes are congruent because the congruence captures everything about that angle or that shape or that line segment, right? When you say equals, that means only one aspect of that shape or that angle is equal or the same as that aspect in another shape. it's the way that I like to explain it is that it's similar to if you take someone or you take yourself and you clone yourself, right? And if you were standing right next to your clone, you and your clone are congruent people, right? Because we took every aspect of you and put it into the clone, right? But if you were standing next to one who is the same height as you may have equal height, so that part of you is the same as that part in the other person, but you are not congruent people. Okay. So yeah, that's my little side note about congruence. Okay. Whenever you see something like this that says the measure of, that's when you use an equal sign. If you don't see the measure of, or for a segment, if you don't see like, if you see a segment, for example, without the little line on top of it, and it's just talking about distance, then you would deal with equal signs. Essentially, equal deals with numbers, like number measurements, so like distance or however big the angle is, or etc. Right? And then if you're talking about the whole angle or the whole shape or the whole line segment, then you're going to use a congruent sign. Okay, back to this justifying statements here. Okay, so my third statement is B is the midpoint of AC. And so what they said is then AB is congruent to BC, right? So if we were to draw this, and I'm going to change my color so you can see it a little better. Okay, if we were to draw this, right, we said B is the midpoint of AC. Okay, so remember when we did this, we know that these two parts up here are equal. The way that we notate that, in geometry, we notate that things are congruent, that segments are congruent using a little dash, right, straight through, okay? If it's an angle, you mark it with little curved lines. Okay, so what that means is that those are congruent. Okay, that's the symbol that we use. Okay, so if we say B is the midpoint, well, that means that the parts are equal, right? That is the definition of the midpoint. That's how I knew that these two parts were congruent because of the definition of the midpoint. Okay. Part D says angle 2 plus ABE equals DBE. I know that you don't have a picture associated with this right now, but what's happening here is we're adding two parts and setting it equal to a whole thing. So that's angle addition postulate. Okay, and then the very last one, E, says if angle 1 is supplementary, then angle 1 plus angle FBJ or FBG equals 180. So I'm using the definition of supplementary to write an equation here. Okay, and what I'm hoping that you're noticing is that in the justifications, a lot of the time you will see a key word or phrase in both that connect, right? Other than maybe the transitive property here or the angle addition postulate, but you'll see in a lot of these, like the if part or the given part had a term in it, and then the reason kind of matched that term. Okay, so I want you all to give it a try here. So let me clear my screen off. All right, so here I gave you a picture, and I realize now that I didn't actually give you the picture on the notes. Sorry about that. So I'm going to draw it really quickly. The drawing is not going to be beautiful, but we will just do the best we can with what we've got here. So we've got G, this is angle 1, 2, this is point B right here in the middle, and then this is angle 5, angle 6, and then we have our points here. So A, E, F, C, G, and D. Okay, so this is the picture that goes with all of these statements. Okay, so I gave you all of the reasons here for that match these. So I want to see if you can match them. All right, so I'm going to pause my video so that I can write some of these things on the right-hand side. You should pause it as well, give it a try, do the matching, and then come back and see if you got the answer correct. All right, y'all, so go ahead and check your answers against mine. So the reason for A was the segment addition postulate, right? If you look at the picture, you have EB right here plus BG, which equals the whole thing, EG. So you're adding part plus part equals whole. So that is the segment addition postulate. Okay. Part B, the correct reason was definition of an angle bisector. So what I want you to notice here is that this time they started with the equation, right? The angle 5 is congruent to angle 6. So then because of that, I know that ray BF is a bisector, right? Definitions can go both ways. So you may start with an equation and end up with a statement, or you may start with a statement and then end up with an equation. Okay, so similar idea for part C. It says if measure of angle 1 plus measure of angle 6 is equal to 90, then angle 1 is complementary to angle 6. Right, so we started this time with the equation, right? We said that these two angles add up to 90, and we know that from the definition of complementary that two angles that add up to 90 are called complementary, right? So we started with the equation and went to the statement. Okay. Part D may have been a little bit tricky because we started out with this really long equation and then went to this shorter equation, right? So if you can look and see what they did on both, you have to look and see what changed from the first equation to the second equation, just like you did when we were doing algebraic proofs. So here, what happened is we got rid of the measure of angle 5, and we did that by subtracting it from both sides. So you can still use the subtraction property, the distributive properties, substitution, symmetric, multiplication, all of those algebraic properties apply to geometry terms also, like our geometry equations also. So keep that in mind that you can still use all of those things. So we did the subtraction property here for part D. And then part E may have been a little bit tricky if you didn't get some of the others, but or if you haven't heard of the term perpendicular before, or the symbol for perpendicular. But this guy, this little upside down T, that means perpendicular. Okay, that's the symbol for perpendicular. So what this is saying is AC and EG are perpendicular. So perpendicular is two lines that intersect to form 90-degree angles. So that's what this is. It says ABG, which is this guy right here. You can kind of see me drawing it on the left-hand side, that is a right angle. Okay, so that's the definition of perpendicular lines. All right, y'all, give me just a second because I'm going to clear my screen. But I've got one more as an example for you that I would love for you to try that's very similar to this one right here. So give this one a try. I'm going to pause this and clear my screen off. 1 second. Okay, so here are your here's your figure and here are your statements. See if you can figure out what the correct reason is for all 6 of those statements, right? And I will see you back here in a second to check your answers. All right, everybody. So if you take a look at the right side of your screen, I filled in the answers here for this example. So the first one is definition of supplementary angle. So see, we started with these two angles are supplementary, so we can write an equation where they add up to 180, right? So that's the definition of supplementary. This is an example where you started with the term and then went to the equation. Remember, definitions go both ways, right? The second one is definition of an angle bisector, right? Very similar to the example that we did previously, right? Number 3, segment addition postulate. CB plus BF, part plus part, equals CF, which is the whole thing. Right? Number 4 is the definition of perpendicular lines. So notice that it goes in the opposite direction right? That in the one that we did previously, you started with the perpendicular symbol and then ended up with the right angle. Here, we started with the right angle and then went to the perpendicular, right? But it still applies. It's the same definition because definitions go both ways. Right, for number 5, if you look at the change that happened from the shorter equation in the if statement to the longer equation, the difference is that they added the measure of angle 2 to both sides of that equation. So that means that that is the addition property because we're adding the same figure, the same number to both sides of an equation. Okay, and number 6, there's lots of possibilities that you could have written here. I just wrote one. So it says write a statement using the figure that could be justified with the angle addition postulate. So I just said angle 5 plus angle 6, which you can see here. Okay, angle 5 plus angle 6 equals angle CBH, right? But you could have added any two angles in that picture, really, that are right next to each other, and written an equation from that. You could have added more than one angle. So I could have said angle 3 plus angle 4 plus angle 5 equals angle FBA, for example. Right? Angle addition postulate doesn't just apply when you're adding two things together. It's just all parts added together equals the whole thing. All right, so give me a second, y'all, because I got to clear my screen and do a little bit of adjusting so that you can see things a little bit better. And then we're going to jump into the next part of this, which is I'm going to do an example for you of a full 2-column proof, and then we'll do some justifying statements. We've justified our statements, sorry, already. And then we're going to try to put some statements in a logical order. All right, so I will see you back here in just a moment. All right, folks, so here we are at an example of a geometric 2-column proof. Now, I'm going to preface this by saying that there are a couple of things that are not quite right with this proof, which I will fix on the screen as we go. Okay, the first being that this is not a typical proof because it doesn't start with a given statement, right? Like in the proof, if you remember from algebraic proofs, I told you that the first statement and reason should always be given, right? So really there should be this term up here that says, angle 1 and angle 2 are vertical, okay? They skipped that for this one just because they were trying to show you why this theorem is true, okay? So we have this drawing right here. So a key thing to do when you're doing a geometric proof is if they give you a drawing, check and see if there are any relationships that might help you, right? So here we have two lines that are intersecting, and so we have these linear pairs here and here. Right, so that may be a good place to start. Right, start with the picture and see if there's any relationships that you can pull from the picture or possibly from the given statement. So that's what these first two are. We wrote 1 plus 3, angle 1 plus angle 3 equals 180 degrees because they're a linear pair or supplementary angles, right? And same thing for angle 2 plus angle 3 equals 180. Those are supplementary angles, so we were able to write those equations, right? And then what they did next is they combined the two equations, and really I should have said the transitive property right here. Okay, because if you notice, see they both have this 180 degrees in common. So really what we're doing is we're saying angle 1 plus angle 3 equals 180. Which equals angle 2 plus angle 3, right? So we're cutting out the middleman. To get this more simplified equation. So remember, whenever you do that, the reason for that is it's not the substitution property. Really, this should say transitive property. So that's my bad. I didn't realize that before I made this video here. Okay. So again, the end goal is to get an equation where you have angle 1 is congruent to angle 2. So you have to kind of figure out, okay, how am I going to get there? Like, what relationships do I know, or what things can I use from the picture that I know that will help me write an equation? Because I didn't start with one. Okay, so essentially what we did is we combined steps 1 and 2 together into one equation using the transitive property to get to this third equation, this third statement right here. Okay, so then again, we're asking ourselves, once I get to an equation, okay, what did they do to go from here to here, right? What's different? And it looks like they subtracted angle 3, right? So we arrived at step 4 by doing the subtraction property, okay? And then the very last one, going from step 4 to step 5, whenever you go from equal to congruent, or from congruent to equal, 99% of the time, the reason for that is definition of congruence. Okay, so you could just say, you don't have to say congruent angles, you could just say definition of congruence. So the only difference between step 4 and step 5 is the equal sign versus the congruent sign right there. Okay, so whenever you see that, that's definition of congruence. Okay, and notice that our proof statement and our last statement that we have written right here match exactly. Okay, so I'm going to clear my screen, and I'm going to do one more for you, right, and see if you can kind of follow along with me. If you would prefer to try this one on your own, you can pause the video right now. But if not, just kind of keep watching with me here. Okay, so our given statement here is that angle A and angle B are right angles. So we're trying to prove that those two angles are congruent. That's the end goal, right? So here's our starting position, and this is our ending position. Okay, so as always, start with given. Always start with exactly what's given to you, and you can copy the given statement exactly as it's written. I made no changes here. Okay, so what you always want to ask yourself is, what's the next logical step? Or what do I know now, right? If I know that A and B are right angles, what else do I know? Okay, so if I know that angle A and angle B are right angles, I know for sure that they both measure 90 degrees. Okay, so that's what statement 2 says. Measure of angle A equals 90 and measure of angle B equals 90. And I'm going to scroll down here so you can write this on the side here if you wish. Okay, so then I have to ask myself, okay, well, how do I know that? How do I know that that measure of angle A and measure of angle B are both 90? How do I know that? Okay, and I know that because that is the definition of right angles. Okay, right. So next, going from step 2 to step 3, I want to ask myself, okay, I have these equations. Now what do I know? Can I combine these in some way? And I can. If you notice, they are both equal to 90. Right? So this is our trusty friend transitive property again. We have angle A equals 90, which equals angle B. And I know I really should be putting an M in front of these. I'm just getting a little tired and lazy. So here, this is the transitive property. We're going to cut out the middleman here and say that the measure of angle A is equal to the measure of angle B. So that's my statement, and the reason for that is the transitive property. Okay, all right, so now I've just got one more step, and I have that these angles are equal. So now I just have to say, well, if they're equal, then that must mean they are congruent. So angle A is congruent to angle B because of the definition of congruence. Okay, so I'm hoping, like I said when we were doing this, when we were just matching statements to reasons, that you can see a clue for the reason in the previous step, right? You can kind of see a clue or a key phrase that will help you figure out what the reason is. Okay, so remember, the reason is always, how did I arrive at this statement, at this new statement? How did I know that this new statement was true? What geometry rule told me that this is true? Okay, so like for step 2, the geometry rule that told me that those angles were both 90 degrees was the definition of a right angle. Okay. All right, so I'm going to clear my screen here, and we're going to do one other part of this 2-column proof process, which is to arrange our statements. And like I said, I'm not writing this on the right-hand side, which is your guys' notes, but everything that you see on the notes is exactly the same as what you see in the slides on the left side of your screen. So you can definitely write things in your notes from there as I write them here. Okay, so we have right here on this slide the statements and the reasons, and we just have to put them in a logical order. Okay, so here we are given that A and B are both complementary to C, and we have to prove that A and B are congruent. Okay, so easiest thing to do is start with what's given. So this one has to be step number 1. Okay, another easy one to pick out is the prove statement, because that always has to be your very last statement, right? So I want to look for the one that matches the proof statement, which is right here. So that's got to be statement number 5. Okay, so now what I'm going to do is go back to number 1 and then put the rest of these in the correct order. Okay, so statement 1 says A and B are complementary to C. So I kind of want to ask myself, okay, if they're complementary, then what equation could I write? Or what do I know about them? And what I know about them is that they add up to 90. So I want to look for the equation on here that has angles that are adding up to 90, and that's this guy right here. And notice that there's 2 of them, right? A and C, and B and C, because we have both. It says A and B are both or each complementary to C. So this is our second step here. Okay, and then our third step, we have to think about, okay, if here's my second step, how could I combine those 2 equations, right? And I can combine them with the transitive property, because see how they are both equal to 90 degrees? So up here, I have the transitive property, and I've combined my 2 equations. So that's my third step. Okay, and then obviously the only one I have left here is my fourth step. But notice that it's the subtraction property. So if you look up at this one up here, statement 3, what I can subtract is angle C from both sides, right? And that gives me statement 4. And then it flows logically, because we went here, we have the measure of the angles is equal. So that means the angles are congruent by the definition of congruence. All right. So give me 1 second here to clear my screen, and then we're going to do one last one where I'm going to put all of this together for you. So I'll see you in just a moment. All right, folks, so here we are at the end of this video, and we're going to put all of these ideas together into one full proof. Okay, and this one is going to look a little bit different from some of the other ones. This one's a little bit more complex, but I wanted to show you a slightly more complex proof so you can see how other ideas that you have learned about already and that you know about fit together. Okay, so here I have this lovely picture right here, and notice that you have some things that are marked as congruent. They have these little symbols right here, the little dash symbols. That means congruent. So that's a piece of given information, and they told me that DE bisects both of these sides. So this side of this triangle and this side of this triangle are both bisected. Okay, so I'm going to start with what's given to me, with the end goal that I'm trying to show that these 2 segments, these 2 sides, AB and BC, are congruent. Okay, so I'm going to start with what's given, and I'm going to try to write all of it out. so that you can see exactly what you would write. So we're going to write our given statements exactly as they're written. Okay, so BD is congruent to BE. DE bisects, and I'm going to abbreviate. You shouldn't, but I'm going to abbreviate just so that I can write this a little bit faster. Okay, DE bisects AB, and DE bisects BC. Okay, so I wrote it on a couple of lines, but it's still all one reason, which is given. Okay, so I want to take the information that I have here in statement number 1 and see if there's another relationship that I can write based on statement number 1. And there is, right? I can use this bisector idea to write another congruence statement, right? Another equation where you have two things that are congruent. So if DE bisects AB, then that means AD, this part, and BD, this part, are congruent. Okay, so I can also do the same thing with the other side. If DE bisects or cuts CB or BC in half, then that means this part, BE, and this part, CE, have to be congruent. Okay, so that's what I'm going to write, that AD is congruent to BD, and BE is congruent to CE, right? And the reason for that is the definition of a you can say a segment bisector, or you could just say definition of a bisector. Okay? All right, so now I have a bunch of these things that are congruent. Do you see how I can make a bunch of connections? Like AD goes to BD, which goes up here. BD goes to BE. BE goes to CE, right? So we're going to end up being able to say that all of these are congruent. All of these segments are congruent, okay? But I don't really have any way to write AB right now. I have to introduce both of these line segments somehow, AB and BC, right? And the easiest way to do that is to write an equation where you have some segment addition going on, right? So I'm going to write a segment addition equation that line segment AB equals AD plus BD. Right? And I can do the exact same thing for the other side, right? BC is congruent to, sorry, I should be writing this as congruent, is congruent to BE plus CE. Okay, so now what would be really awesome is if these two, let me change my color here. What would be really awesome is if these two parts, the addition part, if those were the same, right? Because then we could combine with the transitive property. But do you see how we have all of these segments that are equal? So I can plug BE, I can plug AD in for BE. And I can plug BD in for CE because they're all congruent, right? That's what all of these statements are. This one, and this one. It allows us to make this really long chain of, right, AD is congruent to BD, which is congruent to BE, which is congruent to CE, right? They're all congruent. So I can essentially use the transitive property, or you can think of it as a substitution property, where I'm plugging a bunch of stuff in for everything else. Okay, so let's go ahead and do that. I just realized I didn't write my reason for number 3. So my reason for statement 3 is the segment addition postulate, because I added part plus part and I set it equal to the whole thing. So the segment addition postulate. Like I said, again, I'm abbreviating. You shouldn't. Okay, so for number 4, what I need is I need for this equation, this one, BC is congruent to BE plus CE. I need this, BE plus CE, to turn into this, AD plus BD. And I'm going to do that just by, I can substitute in AD for BE because I know that they're congruent, right? Because they're all congruent in this long chain. And I can substitute BD in for CE because they're all congruent in this chain, okay? So, but since we're dealing with a chain, this is technically the transitive property, right? So I'm going to say BC is congruent to AD plus BD, right? Because remember, the goal is I want the addition stuff for AB and the addition stuff for BC to be the same so that I can put them in a chain and cut out the middleman, right? So this, I did this using the transitive property, but you could have called it substitution. That would have been okay. All right. So now logically, I have enough information to put AB and BC together, right? Now what I have is AB is congruent to AD plus BD, which is congruent to BC. So what I'm going to do is cut out the middleman and say that just these two on the ends are congruent, which they are. Okay, so we have AB is congruent to BC, which is exactly what I wanted, right? That's my end goal because that's my prove statement up here. Okay, so then my reason for that, again, is the transitive property. All right, y'all, so that is your notes video for 2-column proofs. I apologize, I know this one was a little bit long, but proofs take a lot of explanation because it's kind of a new idea and something that you probably haven't seen before now. So it takes a little bit of time to wrap your head around it. But I'm hoping after going through the parts and then putting it all together at the end that you feel like you can take a stab at writing a simple 2-column proof. So I will see you in the next video to do some practice proofs for you. Bye, everyone.